I want to introduce our first speaker of the day, Rob Harkness. Rob is Director of Customer Success for the EU and UK at Biosero and is joining us from Camberley in the UK. Hi, Rob.
Hi, everyone.
Good to have you. How are you doing?
I'm very good, thanks. Glad to be here.
So, Rob, you will talk about laboratory automation, right? I think many people maybe have a little bit different views or ideas what that really is. Can you just very briefly tell us what is that exactly?
Well, within any lab, there's a whole variety of different instruments. There's centrifuges, there's balances, liquid handlers, and what have you. And of course, you can run those manually. But by using automation, you can increase your productivity, get better repeatability. So link all of those pieces of kit together to run the experiments that you do day in, day out.
Very cool. Yeah. And how did you come aware of Knime in this context?
Well, I mean, I will touch on it very briefly in the presentation, but it's just from talking to customers. You know, my role is very much about getting out there and speaking to people, and it's something that started being talked about, and I've noticed that over the last couple of years. So that kind of sparked an interest, and that's why we started talking, right?
Yeah, excellent. Cool. So now I think it's time for a presentation.
Okay. All right, well, hi everyone. My name is Rob Harkness, Director of Customer Success for Biosero here in Europe. Now, in this short talk, I'm going to cover why we want to integrate within labs, what we should be integrating, and how we can go about this. Okay, so to start, I want to cover what integration is, and in simple terms, it's about allowing various independent components to work together with some form of benefit. Now, historically, integration or connectivity has significantly impacted our lives. Before the first industrial revolution, business was very regional as transporting goods was difficult. But the increased use of rail suddenly allowed producers of goods to distribute their product on a much larger scale. In South Wales, for example, linking the coalfields there to the seaports increased their coal output by 3,000% over a 30-year period. And that was all because of connectivity. So integration and connectivity benefits all of us. You know, think of where we'd be without the internet, which of course everyone's using right now. Now, it can be complicated, especially systems integration, and technically it normally requires a team of experts. And then there is the change management aspect, where even the best initiatives can be derailed by preconceptions and perceived issues. Things are changing though. I mean, tools have appeared with a real focus on making integration simple. Take the home automation market. I'm sure many of you have got a Amazon Alexa at home, or a Google smart speaker, smart camera, lights, TV, and so on. And these devices are great on their own, but the value of my Google speaker increases exponentially when I have the power to link it to other devices or services. Now, I'm using at home, I'm using a tool called If This Then That. Bit of a tongue twister. A web app with a real simple interface. And I have apps set up to alert me when my outdoor Nest camera spots someone, or I get it to turn off the lights in my kid's bedroom. Saves me having to go upstairs and turn them off myself because they're always leaving them on. Now, this type of software is called RPA, and that stands for Robotic Process Automation. It's not a robot in the physical sense, but think of it more as a software agent that performs a set of actions based upon predefined rules triggered by some event. Now, these are really useful when you automate repetitive tasks. And the example I'm showing you here on screen shows that a manual process for processing emails was taking 2 hours before, but now takes 8 minutes. So that's a huge improvement. And combined with the fact that this process really makes mistakes, you've got something which is so much better than running it manually. And it's all made possible by integration. Now, digital transformations are happening everywhere and across all industries. RPA is ubiquitous within the banking sector, where they have to be able to get the right result or decision or calculation every time. They need complete audit trails, essential for compliance. They need to be able to free up people to do more value-added tasks, and that ability to instantly ramp up or down to deal with spikes in demand is extremely valuable. Now, these are all benefits that labs want as well. I mean, digitalization can really help the reproducibility crisis that exists, I'm sure many of you are aware of, which is for addressing root issues such as scientists having to repeatedly input the same barcode manually into multiple systems as part of just a single workflow. Now, one type of digital transformation that we see becoming more common is end-to-end integration. It's that goal of taking a lab workflow and managing it from start to finish in a digital manner. Now, whilst desirable, it doesn't necessarily mean that each step is fully automated with a robotic arm. People can still be involved, but the goal is that the data flows seamlessly from beginning to end. You know, take a workflow in a pathology lab. Once a set of tasks have been ordered against a sample, the the process from accession through to the end result should be seamless. People may still be moving those samples manually between each step, you know, taking the samples off the RNA extraction instrument to the PCR prep lab, but they are told what to do in a controlled manner, and there is sample tracking throughout. So digital transformation is as much about people as it is about using the latest technologies. And it's really important that everyone involved in the lab understands this vision and that everyone is on board. However, you must also have the tech tools to support this. We must be able to take different instruments we find in labs, LIMS, electronic notebooks, sample management platforms, and integrate these to allow orchestration of experimental workflow tasks. The flow of data is crucial here, and we must be able to integrate this and securely, and one would hope adhering to fair principles as well. Connections to data analysis tools that themselves can employ AI, machine learning opens up so many possibilities for any type of lab. And this is why end-to-end integration is so desirable. So what I'm going to show you here is a short video of what we call our acceleration lab at Biosero. It's a glimpse of how laboratory automation can be deployed. And in this case, we're using a mobile robot on an overnight run to move samples to other islands of automation within a lab. So you can see that's picked up the rack of samples, it's moving it over to another station. There we have a robot just handling vials instead, another one working with a centrifuge and a thermo kingfisher. So real short video there, just to give you a glimpse of what we're talking about here. And as you can see at the link at the bottom there, you can find out more on our website and even book a tour to see more of what's going on inside our lab. So we can handle a variety of automation approaches, from guiding a scientist through using a manual pipette, right through to a much larger architecture where we have multiple islands of automation using a conveyor belt platform and common sample storage areas, which you can see there on the right of the screen, bottom right of the slide. Now, there are a number of laboratory automation scheduling tools available on the market today that allow experiment workflows to be defined and tracked. And I've already discussed what we need for end-to-end. But on top of that, there are some other considerations. It should be, the tool that we have should be dynamic and flexible. Executing rigid workflows is great for some assays, but many need flexibility to deal with the events that occur, and a good scheduling package can handle that. Connectivity with data and instruments is a given, but we need to be able to configure this easily and fast. Research labs move at a really fast pace. Now, all of this is great, but if the tool is not reliable, it's all in vain. So schedulers must be able to handle the inevitable errors that will occur when you're connected to such a variety of lab components. So what we have here is a short demonstration of our software, Green Button Go. This is the layout screen where we're mapping the physical instruments which are available. And we have a dispenser, a plate reader there, and a robot in the center. And what you can see on the left-hand side is just some of the different instruments that I can control in our software. But we'll start with a very simple layout. So then we can build up a workflow process. So we get plates from a hotel, we move them to a dispenser where we can dispense a fixed amount of liquid to the plate. We'll incubate for 10 minutes, and then we'll bring the plate out onto a plate reader. And then finally, we'll put the plate back. So it's simple as that to build up a process. Then we click run. It will ask us where our plates are. Let's assume they've already been barcoded. Click the OK button, and then the running will begin. So what you can see on the left-hand side there is different instruments running, flashing up in green, and we have on the right-hand side a Gantt chart. We're running this as simulation, so it's obviously a lot faster, but we get a Gantt chart so that we can see exactly how our samples are tracked. So we actually automated through the lab. And it also allows operators to know when the automation is going to finish, because they probably then may need to take the samples onto another another instrument or automation platform that they have within their lab. Okay, so we nearly have end-to-end integration covered, but there is one thing that is missing, and that is data analytics. Now, I've seen a growing number of labs using Knime, as I said earlier, applications ranging from early drug discovery through to formulation chemistry. Now, in each of these cases, vast amounts of data were being generated by the automation, but that process of getting data into their analytics tool of choice, in this case Knime, continued to be rather manual. So a team of us at which was myself at Biocero, Ciobra, Hit Discovery Constants, and the CELA Consortium, Standards in Laboratory Automation, we decided to embark on a pilot project to get Knime integrated into a laboratory automated lab workflow. The initial concept was all about moving an assay microplate, perhaps with fixed cells with already dosed with compounds, to a microplate reader, perform a single endpoint measurement, perhaps fluorescence, and then pass that data back to Knime to be processed, and then model a dose response. And you can see that kind of concept there on screen. With this architecture, you could also do a closed loop process. For example, bioprocessing for cell and gene therapy, using Knime to optimize the PID loop parameters based on the inputs such as cell count, paddle speed, temperature, mass spec data, etc. Now, whilst Knime and ourselves with our Green Button Go software have exposed APIs, this would have resulted in a very concrete implementation. And we decided very early on that we should use a standard such as CELA, which would allow Knime to work actually with any other service that supports CELA, not just our software, Green Button Go. And also by working to a standard, the implementation is faster and tends to be more reliable, and that's what we experienced during this POC. Now, what was finally implemented was a little bit different. It was a method that allowed a shared component in Knime to pull the data in from the CELA server, Green Button Go in this case, and for that data to be formatted, processed, and then for that data to go back to Green Button Go so it could be used for the next experiment. Essentially, the building blocks for design, build, test, learn closed loop approach. As was said earlier, much more information about this can be found within the blog section on the Knime website. So to finish, I'd like to take you back to that home automation example. These software tools are fantastic apps on their own, but when you integrate and you connect them up, that value grows exponentially. And the lab is no different. Automation is happening, a stacker feeding in a plate washer, right up to a large multi-arm high throughput experimentation platform. And that adoption is growing. However, if moving data from upstream or downstream, interacting with your LIMS or ELN, or analysing results still requires a great deal of effort, this means the lab is not running as efficiently as it should. The community is starting to demand more, especially as the tools exist right now for end-to-end integration. Now, I'm hoping that I've managed to show you that Green Button Go, interacting with Knime, and using an established standard such as CELA is an extremely powerful proposition. This demonstrates how the tools are ready today for end-to-end integration, and it's something that any lab, big or small, can achieve. Thank you for your time.
Thank you so much, Rob. Very, very cool. I think we have a little time for questions from the audience. Janina, do you have something for us?
Yes, there are questions from the audience. So the first question is, how many people or labs are currently using those mobile robotics?
Admittedly, it's a very new technology. In our case, we have about 6 different labs now using it. And I know of a few other companies that it's starting to roll out, two or three in that case. But I would say that certainly the larger pharma companies are interested in this. It's just a paradigm shift. Right now, well, traditionally, it's always been a robot arm with the instruments around it. And there's been advances where you can undock instruments and take them away. But essentially, the robot or the mover technology is fixed. And it's flipped it around now. The mobile robot actually moves to where your instruments are. So you don't have to disrupt your existing lab setup. You don't have to change that whole infrastructure. And of course, they can work around people as well. Yeah, I think you're going to see more and more of this kind of technology in labs going forward, for sure.
And then there's another question. advantages did you see in using Knime? How easy was it to integrate in your system, an example, with other services?
As in, how easy is it for Knime to integrate with other services or our software?
How easy was it for you to integrate it in your system?
Oh, I mean, we were already working with getting a sealer connector into our software. So and developing an interface which means that our software is a sealer interface. So we were all. I mean, that was I didn't say it in the talk, but that was another reason why we went down this path. You know, we see a lot of value in sealer. Immediately when our sealer driver was available, we suddenly could integrate with another 20 devices which were available on the market. You know, it's an extremely powerful way of doing integration, and it means that anyone who then creates a sealer interface for their device, they can then use it with our software. So, I mean, for me, it's if you're going to create an interface now for a new laboratory device, why wouldn't you use a standard like sealer? It seems crazy to go about developing your own proprietary interface.
Why reinvent the wheel, right?
Yeah. Well, exactly, and especially the error handling conditions. You know, I mean, sealers thought about that quite a lot. So, yeah, again, why reinvent the wheel?